So you are going to want to draw this at the top of every paper. I just keep it on a stick-it note so I can kind of pull it out and I write it on the board so it's there for you to see. All right. Sine is the y value. So for all of these, we're going to just go around our unit circle and pull all of the y values. Okay. This is not hard, but you have to stay organized and focused with what's going on. So sine of 0 pi, which one of these is 0 pi? Up, down, left, right is like a word I'm looking for. To the right. Okay, this one. What's the y value for this point? 0. Perfect. Now we're just going to go around the circle. Pi over 2 is up here. That's this point. What's the y value? 1. How about the next one? 0, -1. Then you're back where you started. Now we're going to go around the circle backwards. If you rotate backwards pi over 2, where does that put you? Yeah, it's going to be at the bottom, right? So -1. Negative pi is actually at the same place as positive pi because it's on the opposite side of the circle. So that y value is 0. If you go backwards 3 pi over 2, and basically just watch me point to this. You start here. If you go backwards 3 pi over 2, you're at the top of the circle. That'll be 1. And if you go backwards 2 pi, it's where you started because you're back to the beginning of the circle. So that would be 0. Are we all together there? That should not be difficult. It's just you have to stay organized. So draw your little circle, draw your little bullseye. All right, now we're going to plot the points. Do you know how in Algebra 2 and the first half of this year, we went through all the functions? We did parabolas, you know, quadratics, the U shape. You have cubics, you have absolute value, you have exponential, which is the swoop. You know all those different shapes of the graphs? You're just about to learn a new shape. Are you following me here? Like you knew all the parent functions, you're just learning a new one, okay? So let's go ahead and graph these. You're going to start at 0, 0. So the origin right here. All right. And then your next point is pi over 2, 1. Do you see how we got that? Pi over 2, 1. So that's going to be right here. Now I'm going to stop moving the paper up and down because I don't want to make you seasick. For pi, and I know it's super tiny on there, but for pi, what did we get? Is that puts you back at 0. 3 pi over 2. -1, and then at 2 pi, you're back where you started. Now, when we went around the circle backwards, we're going to get our points over here. For negative pi over 2, what did we get? Bless you. Just look back through the list that we just did. It was -1. For negative pi, it was back to 0, then up to +1, and then back to 0. So when you connect those, it's going to be a wave. Couple of things. I'm not here to grade your art skills, but can you attempt to make it be a nice smooth curve? It should not look like a jagged jack-o'-lantern mouth. Do you get what I'm saying? If you did this, I need you to erase that, and I will mark that wrong. I mean, like, make an attempt. It should be a nice smooth curve. Are you following me here? Like, don't do this. If you're like, why is she being hateful about that? It actually does matter in calculus, okay? Also, you don't want to put arrows on the ends of this. What does an arrow mean? Right. Is this going to keep going up forever and ever and ever? No, it's going to continue waving. So just don't put anything. Like you're going to just stop. Okay. It's going to continue doing a wave. Have any of you done physics, like sound waves? Or like, is that from like, no, like a lot of you haven't done physics. Okay, never mind, forget that. I usually get a lot of people, they're like, oh, this is sound waves from physics. And I'm like, yeah, kind of, that's what it is. But anyway, never mind. All right, so some things that we're going to notice about the graph. I want to talk about domain and range real quick. I'm going to like draw your attention to some of the characteristics of this here. Now, I didn't put arrows on the end because it's not going to go up forever or down forever. But it is going to continue waving forever in both directions. So what's your domain going to be? Like left to right? It'll be all real numbers. It's going to go left forever and right forever, and you don't have any holes or asymptotes in it. So everything. Isn't that nice? That's the answer. For sine, what's the domain? All reals. That's the answer. Range. Now, that is not everything. You're stuck between these two numbers. As you go downwards to upwards, what numbers are you stuck between? Bracket versus parenthesis conversation. Are there actual points at -1 and +1? Yes. So you want brackets. And I'm just going to draw your attention to a few other things here. This function is continuous. Do you remember? No, you're like, no. Back in unit 2, when we talked about continuity, Do you remember removable discontinuities and non-removable discontinuities? And you had the whole, okay, good, ringing bells, heads nodding. Okay, anyway, this one's continuous because you can trace it with your pen without lifting off the paper. Okay, there's no like problems with this. Sine is what is called an odd function. We did this too, you might not remember that, odd and even functions. Does that ring any bells? That was back in unit 2 as well. Anyway, odd means that it is symmetric to the origin. So symmetry to the origin. Can't write and talk at the same time. I'm bringing that up because whether they are odd or even, I'm going to tell you this for all 6 of them, whether they are odd or even comes up later. So this isn't something that you necessarily need right now. I'm foreshadowing. Do you get what I'm saying? It's going to be important later, so I'm just bringing it up now. Okay. What is the y-intercept for this one? Which is actually also the x-intercept, right? But sine starts at the origin. That's an important thing to just remember. So sine starts at 0, 0. And we're also going to talk about this when we get into like graphing these in more details, what's called the period of the function. That's how much space it takes to complete one full cycle. So to get back where you started. All the trig functions are what are called cyclic because you keep going around and around the unit circle. So like how much space does it take to get back where you started? Well, look at this. Do you see how we started at 0 pi? It goes up, comes back to the middle, goes down, comes back to the middle, and that's one full cycle. Like it goes up, goes down, comes back. That's one full rotation. Well, how much space does that take up? It's from 0 to 2 pi. Does that make sense that it's 2 pi? It should, because 2 pi is what? The whole circle, right? And whoever said 360 degrees, you're not wrong, but we are done with degrees. Kiss them goodbye, okay? We're not doing any more degrees. I know, right? Sad. Actually, radians are better, so get used to it. Here's what we're going to do. I want you to flip over, and I'm with your group. I want you to try to recreate what we just did. The only difference is this says cosine. So when you go around this little circle, instead of pulling all the y values, you're going to do the exact same thing, but you're going to pull all of the perfect x values. So I'm just going to go and pull all the x values. So like, what's the first one? Because if you get the first one, it usually kind of flows from there. First one is 1, and then 0, -1, 0, 1. And then when you go backwards, it'll be -1, 0, +1, 0. And so you're going to take those and plot them down here, and it's going to look exactly the same as the one we just did, except for where it starts. Instead of starting at the origin, cosine starts at 0, 1, and then does this wave. Now, I heard you guys saying it's a W, but like, do you get that this is going to keep going? Like, I could fill this in more. Do you see what I'm saying? Like, if you wanted to continue it to the very edge of the paper, like, it's just going to keep waving forever. Go ahead. Yeah. Oh, I wrote the wrong one there. You're right. And of course, I'm writing with pen. I was just off by 1. I'm sorry. There we go. I fixed it. Thank you. Because I'm going to take a picture of this and post it. I don't want to post it wrong. Okay, so some things we notice. What is our domain? Don't put arrows at the end, but yes, all reals, because it's going to wave forever. And there aren't any holes or any other problems in it, so you get everything. Range, again, -1 to 1 with brackets, because there's actual points there. There aren't any asymptotes in this graph. And again, it's continuous. And the reason I'm bringing that up is today we're only doing sine and cosine, but later we're going to do secant and cosecant and tangent and all those. Those ones aren't. So I want you to be able to tell the difference. Cosine is an even function. It has symmetry to the y-axis. And again, that's not super important right at this moment, but like next unit and the one after, it is going to matter. You're going to have to know which ones are odd and which ones are even. So I'm bringing it up now so that when we get there, it won't be the first time you're hearing it. Now, on the other side of the paper, we said sines started at the origin. Cosines y-intercepts is 0, 1. That's how I tell the difference is where the starting point is, because otherwise they look the exact same, don't they? Like otherwise you really can't tell the difference. They're just a wave. So if you figure out where they start, then you're good. And last thing I want to bring up is the period. That's how like much space it takes to complete one full cycle. Again, it would be 2 pi because that's once around the unit circle. All right, so now what we are going to do is take those parent functions, because what we just looked at were the parent functions, and we're going to do all the transformations to them. So all the shifts and stretches and shrinks and reflections and all of that stuff. As a heads up, today we're doing this for sine and cosine, but the idea and the concept is the same for all of them. So I'm almost essentially teaching all of them at once right now. And when we get to the others, it's going to be the same process, but a different shape of the graph. Is this making sense? This is kind of like one-stop shopping for this unit, okay? Because all the information is not going to change. So here's how your function is going to look. You're going to have y equals or f of x equals, and you're going to have some sort of coefficient out front. As a heads up, it's going to look like the alphabet threw up on your paper, okay? So we call that a. Now, what I usually write right here is trig, because it could be sine, cosine, tangent, cosecant, secant, or cotangent. It's going to be one of those 6, but I just write trig there as a placeholder. Do you get what I'm saying? Yeah. For today, it'll be sine or cosine, but like one of those. All right, and then brackets, and inside of here, you're going to have b times x minus c, and then plus d at the end. So you have these a, b, c, and d that are in there, and I'm going to go through and explain to you what they all mean. But it is not any different from what you have learned before. So the first one we're going to look at is called amplitude. It is the absolute value of A. In other words, that is your vertical stretch or shrink. We just call it an amplitude. The reason there's an absolute value is when you have a wave, the amplitude is by definition the distance from the center line. So you have that center line. The amplitude is how far away you get from the center, and a distance can't be negative. So we put an absolute value around it. It just can't be negative, but that's the vertical stretch or shrink. Period. What was it on our little intro sheet? What did we get for the period for both of these? 2 pi is what it typically is, because that's once around the unit circle. You're going to divide by absolute value of b. That's the horizontal stretch or shrink. So what it does is it takes your wave. Oh, let me get my slinky jot out. Do you remember me doing this before we did it here? Do you remember this when we did the stretches and shrinks? Yeah. You're going to take your wave and do something like this. The slinky? All right, so you're going to take the wave and stretch or shrink it, okay? Again, the reason there's an absolute value there is the period is a distance. It's the distance it takes to complete one full cycle, and a distance just by definition, forget that, isn't negative, okay? So your distance isn't negative. Phase shift is going to be the C value, and that's how much you move left or right. We just call it phase shift. You're just going to get used to some new vocabulary, that's all. And then vertical translation is D. That's how much you move up or down. So that's how each of those letters kind of affects the thing. Now your range, and I'm going to draw a little picture to go with this. Your center line is typically at 0, but if you move the graph up or down, it's going to be that amount D. So that center line is going to be at D. For example, if you moved up 3, the center's at 3. Following me now? If you move down 2, it's at -2. So wherever that is, that's D. You're going to have this wave. And this distance from the center is A. The distance that you get away from the center is that A value. So when you go to do your range, it's going to be this low point to the high point, how could you get this value, like the lower one? D is where you're going to start, and then minus A. So your low point is going to be the center minus the amplitude. So D minus A, comma, and then how do you get the high point, like the tall part? D plus A. So it's the center plus and minus how far away you got. Okay. So now we're just going to try a few of these. All right, we're going to take them and stretch them and shrink them and do all this stuff to them. All right. So do you see how this says sine? It's a wave. So what's the domain? Just automatically. All reals. That's an automatic answer. Now I'm going to skip the range for just a second. Amplitude would be absolute value of 3, which is 3. All right, the period is 2 pi over b. Now, b is whatever's in front of the x. Follow me here. I'm going to point to this. B is whatever's in front of the x. I'm going to start off with a simple example. Obviously, I'm not going to do the hardest example first. What do you see in front of this x? There's nothing, so it's a 1. So this would be absolute value of 1, which is just 1. And 2 pi over 1 is 2 pi. What that means is it did not stretch or shrink. So we didn't do this. Do you get what I'm saying? It just stayed the same. Again, I'm trying to start off with an easier example. Phase shift is left or right. Do you see parentheses in here with the x? No. So you can say 0, it didn't do that. Or you can write the word none. You can put NA. You can put a frowny face. You can put like ha 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 ha. I don't know. You have to put something on that line though to indicate that there isn't one. And then your vertical translation is the -4, or you could write the word down 4. Some people like to do that because it reminds them of stuff we've done before. You could write down 4, and that's all fine. So now when you go to do your range, this center line, look at this picture, but we're going to like fill in the D and the A. The center line is at -4. The whole thing, the whole party moved down 4. Okay, so that center's at -4. And we got 3 units away from it in each direction. So what's your low value going to be? It'll be -7. So -4 is your center. If you go down 3, it'll be -7. If you go up 3, it'll be -1. Good. Now here's the other option you have. You can wait until you get the visual and just kind of look at it to do the range. Here's the only thing with that. Don't forget to go back and answer it. Because what'll happen is people will be like, oh, I'll come back to that. I'll do the graph first and then just kind of look at it. And that's totally fine. Just don't forget to answer it. Okay. Now, when you go and set up your table, in the very first box, you're going to put your phase shift. So instead of starting at 0, you're going to start wherever it shifted. Now, again, I'm trying to start with an easy example. This one didn't have a phase shift. So you're going to, yeah, W. So you're going to just start at 0 pi. No, actually, if there's not a phase shift, that actually is a huge W because you get to start at 0. Okay. All right. And then to fill in the rest of it, it's going to be the period of the function. I cannot write and talk at the same time. Dyslexic moment. Thank you. It's going to be the period of the function because you want to finish one full cycle. So what did we say was the period of this function? 2 pi. Okay, so question. If you start at 0 pi and you want to go a distance of 2 pi, you're going to end up at 2 pi. Now, again, I started with an easy example, but they're going to get harder. And it's you have to be able to break down fractions. So let's have a quick conversation. If you had a whole, it would break down into halves. Follow me there? Half and half. How would halves break down? Fourths. Good. And then how would fourths break down? And then in theory, I wouldn't do this to you, but how would eighths break down? 16ths. Coming with me there? Now what? Yeah, like a ruler. Now what if you had thirds? How would thirds break down? 6. And then I wouldn't do this to you, but in theory, sixth would break down into 12ths. You have to be able to negotiate fractions. Okay, are we together here? So what is halfway between 0 and 2? 1 pi. And then halfway between 0 and pi is a half a pi over 2, and then this would be 3 pi over 2. Again, I tried to start with an easy example, so it's just the unit circle. But listen to this, and I'm going to say this every single class until the test. It actually doesn't matter what that says. And if you can't get it, like always, what do I tell you to do? Make something up. And if you're going to make something up, please use these. Okay, if you can't get, you'll lose a point, but then I can read with you. No matter what that says, you are going to go around your unit circle. In fact, I'm going to cover that up because it just doesn't even matter what it says. Now, I always use another color for this. The unit circle gives you the trig part. So that's the sine, cosine, tangent, secant, cotangent part of it. You still have to do the stuff that's outside. So we're going to go around the circle, multiply by 3, and then subtract 4. Like you have to do the other stuff that's there. This is sine. So are we using X or Y as we go around? Y. Okay, watch. Just watch. What's your first Y value? 0 times 3 is 0 minus 4. Now we're up at the top. What's your Y value? 1 times 3. 3 minus 4. Negative 1. Now we're over here. Your Y value is 0 times 3 is 0 minus 4. Negative 4. Now we're down here. What's your Y value? Negative 1 times 3 is negative 3 minus 4 is negative 7. And then what's the last one going to be? Yeah, back where you started, so negative 4. Now we're going to take that information and plot it over here. Here's what I would do, because this needs to go all the way down to negative 7. I would include some extra tick marks right here, because otherwise it's going to go way off the grid, like negative 7 would be down here. So add some extra tick marks in. I don't need you to label every single tick mark on the x-axis. If you label like at least 2 of them, we're good. If you want them to count by halves, do you see how these count by halves? I want this one to be a half. That means the next little tick mark would be a whole pi. And then this one would be 1.5. And then I want this one to be 2 pi. And then I'm going to skip one. And this one would be 3 pi. That's good enough. I don't need you to label all of them. That would be tedious and annoying. All right, just label 2 or 3. How about I'll say this? If you label at least 2 of them, I'll mark it right. Can we do that? At a barest minimum, I need you to label 2 of them. Okay, cool. Now we're just going to take that information and plot it on here. 0, negative 4. That would be right here. 0, negative 4. So our first point is right there. Then you get pi over 2, negative 1. So here's pi over 2, and then negative 1. Like here, we're just plotting points at this point. So right there. And then pi is negative 4. So back to the center line. And then negative 7 would be right about there. And then back to the center line where you started. And so it should look something like this. Now the directions on your test are going to be show 2 full periods. I don't care which direction you go, but you just have to show me that you can continue the pattern. So where's our next point going to be? If this one's at negative 4, where's the next one going to be? Negative 1, and then back to negative 4, and then negative 7, and then back to negative 4. Now you can go to the right or the left, I don't care, but you need to just show me that you can continue the pattern. Now I need to bring this up because this happens a lot and I don't understand why, but I've been doing this for so long, I know what the common mistakes are. Do you guys see how there's a center line here? Like, and you go above the center line and below the center line? Like you're in the middle, up, middle, down, middle, up, middle, down. A common mistake that happens is people will only put points at the top and bottom and then do something like this. Like they lose the center entirely. And I don't get how that happens, but please don't do that. Okay, that's just a common mistake that I see. Let's try another one. It's sine, so it's a wave. What's our domain? All reals, automatic answer. If you're like, this is taking forever, yeah, the first one kind of does. We're going to be able to speed it up now. I'm going to come back to the range. Amplitude, what's really in front of here? A -1. Now you have to absolute value that, so it will just be 1. Period. It's 2 pi over absolute value of whatever's in front of the x. What's in front of the x? 1/2, bless you. Now let's have a conversation about dividing by fractions. When you divide by a fraction, you multiply by the good reciprocal. So it's really 2 times 2, which will be 4 pi. You took it, and instead of 2 pi, now it's 4 pi. Instead of 2 pi, now it's 4 pi. We stretched it. 2 times 2 is 4. All right, phase shift. There is one in this one. Did we go left or right? Remember how it's kind of backwards? We went right pi. So you can either just say pi, or you can put right pi. Some people like to put the word because it's familiar territory. And then vertical translation. Do you see anything added or subtracted? No. So you can put 0, or you can say none, or indicate in some way that there wasn't one. Now, when you go back to range, where's your center line? 0, because we didn't shift up or down. Coming with me there? 0 is your center. What's your amplitude? So center's at 0. You went 1 unit above and below it. So what's your range? 0 is the center. You went 1 unit above and below. -1 to +1. Good. In the first box, you're going to put your phase shift. So instead of 0, this one is pi. And then you're going to add on the period. What did we say the period was? Okay, so look, if you start at pi and you want to go a distance of 4 pi, 1 pi plus 4 pi is 5 pi. And then you have to be able to break down in between. Now, the good news, the W in this one is that there's not going to be a fraction. Okay, what would be halfway between 1 and 5? 3, good. And then what's halfway between 1 and 3? 2. And then this one would be 4. You guys are silly. Now look, at that point, it doesn't matter what this says. And if you can't get it, what should you do? Make it up. Okay, in fact, I'm going to cover it up because it just doesn't matter. No matter what, you're going to start at the beginning and go around. It literally doesn't matter what it says. You're going to start at the beginning. Where are you going to start? Beginning, and then go around the circle. Now, I do usually block this off. The trig part, the like sine or cosine of whatever, is what comes from the unit circle. We're going to multiply it by a -1 and then add nothing. Do you see how there's plus nothing out here? Okay, so whatever we get, we're just going to basically negate it. All right. Are we doing the y values or the x values? Y, good. What's your first y value? 0 times the negative. Traveling around the circle. Now we're at 1, but we're going to make it -1. What's the next one? 0, and then it would be -1 down here, but we're going to negative the -1. So 1, and then 2. My hope is that once you get the ball rolling, you can just keep it going because it's cyclic. All right. Now labeling the x-axis, as long as you label a couple of them, we're good. We just need to count by pi. So here's 1 pi, here's 2 pi, here's 3 pi. That's good enough for me. They're super tiny anyway. I just need to know that you can count, basically. And then we're going to plot these. So you're going to start at pi 0. So right there. So pi 0. 2 pi is -1. Back to 0. Up to +1 and back to 0. So it will look like that. And then again, I just want to see that you can keep the pattern going. So you have to do one more cycle. So where's my next? I'm just going to keep going to the right. If there's space, I usually just keep going to the right. Where's the next point going to be? at the next little tick mark. It'll be down, and then back to the center, and then up, and then back to the center. Hanging in there? Okay. So those were both sine. If you flip over, what does the next example say? You're going to do the exact same thing, though. The process is not different. The only difference is when you go to the circle, what are you going to do? X values. Perfect. All right, here we go. What's the domain? Yep, negative infinity to infinity. It's an automatic answer. Amplitude. What's in front of the cosine? A 1. So the absolute value of 1, which is 1. Period. It's 2 pi over absolute value of whatever's in front of the x. So what's in front of the x for this? 2 pi. Oh my gosh, what's going to happen with that? They cancel and you just get 1. Uno. All right, phase shift. This is your left or right. And remember, it's kind of backwards. Which direction does this one go? Left a half. So you can put negative a half, or you can actually write the word left 1/2. And then vertical translation is up or down. Down 1, or you can just put negative 1. Bless you. Bless you. So your range, your center line is at -1. So imagine that in your imagination. The center is at -1 and your amplitude is 1. So -1, and you want 1 unit below that and 1 unit above that. So we're centered at -1. It'll be -2 if you go down, and then 0 if you go up. Again, if you want to wait until you get the picture to do that, that's fine. Just don't forget to go back and answer it. All right, what goes in the first box? Phase shift, good, -1/2. And then you want to go 1 full cycle, so add the period, which is 1. So -1/2 plus 1. Now that's actually a really big W as well, because what's halfway between -1/2 and +1/2? Good, 0. Now you have to break down the halves. How did we say halves broke down? Fourths. So this one's -1/4, and that one's +1/4. But the bottom line is it doesn't matter, and if you can't figure it out, make it up. Where are we going to start? The beginning. Now for this one, we're going to pull our X values. Here's the trig part. We're going to multiply by a we're going to multiply by a +1 out front, which isn't going to change anything. And then we're going to subtract 1. So basically you're going to get your values, subtract 1. We're just going to do X because it's cosine. What's your first X value? 1, -1. Good. Then the next one's 0, -1, -1. Now we're over here. We're just going around the circle. Your X value is -1, -1, -2. And then your next one is 0, -1, be -1, and then back where you started. You're going to take that and put it on the graph. Now you want to count by fourths. Here's how I think is the easiest way to do this. Watch. Well, you can write 1/4, 1/2, 3/4, what if you want to, but what I would do is this one's going to be a fourth, 2/4, 3/4. This is the one that I want to be worth 1. And then you can just count out again and then make like 4 tick marks later. This one's going to be 2. Like a ruler. I like how you said that. Like a ruler. Like make it like a ruler. I like that. I'm going to use that from now on. It's like a ruler. You're just putting the tick marks on it. And then we're going to plot everything. -1/2 would be this one. I want that to be 0. Remember, each tick mark is a fourth. -1/4 would be -1. That's right here. 0 is -2. And then -1, and then back to 0. Remember, cosine doesn't start on the center line. It starts above it. And so I want you to just continue the pattern for one more cycle. So where's the next point going to be? Like if I continue this, right? Yeah. Like, does your brain just do a right there kind of thing? Like at that point, you're not really thinking about the numbers. It's like right there. And then it's going to be down and then back to the center and then back up. And it'll keep doing that forever. We're just going to try one more. I'm not going to do that last one there. I don't like that last example in there, but we're going to try one more. We can do it. What's our domain? Oh, that's an automatic answer. On the test, they're all worth a point. So that's like a point you're going to get. All right, amplitude. It would be absolute value of which one of these numbers? 1/2, which would be 1/2. Period would be 2 pi over absolute value. Good, whatever's in front of the x, which in this case is 1. So your period would just be 2 pi. We did not stretch or shrink it. Thank you for focusing with me up. We need to do you get that you have to do a few of these before it starts to sink in? Like, not trying to torture you, but you have to do a couple of them. All right, phase shift, left or right? Left, pi over 4, or just negative pi over 4. And then up or down? None. So that means your center is at 0. You didn't move up or down. And your amplitude's 1/2. So imagine the center at 0 and you went 1/2 in each direction away from it. So what would your range be? Centered at 0. Yeah, negative 1/2 to positive 1/2. It's like an elephant came and sat on it. Your wave is going to be shorter. What goes in the first little box? Good, phase shift, negative pi over 4. And then you have to add on the period. Here's where this becomes fun with fractions. I'm going to write this off to the side so you can see it. And I'm going to leave out the pi. We'll just put pi back in. You have to take negative 1/4 and add 2. How many fourths is a whole 2? Good. So what will that give you together? Oh my gosh, you guys are... The fact that you guys can do that without it being me pulling teeth is so awesome. Now you're doing what's halfway in between, okay? I would ignore the pi and I would ignore the 4. This is a -1 and that's a 7. What is halfway between -1 and 7? What I'll sometimes do to help people is draw a number line. Oh. But it sounds like you guys can do it without a number line. But if you can't, draw a number line, and do you see how the -1 and 7, and what you can do is just kind of leapfrog your way to them. Oh, it's not 4. It's not 4, it's 3. Do you see how I did that? Look, can you guys watch? I'm pointing to it. Like I'm starting here, and then you go in again. 3. Okay, so it's going to be 3 pi over 4. If you said 4, what you probably did is you skipped 0. I think is probably what happened. Yeah, I know, 0, right? And then what's halfway between -1 and 3? 1. So that would be just pi over 4. And then what's halfway between 3 and 7? 5. So 5 pi over 4. However you get through that is fine. But again, it kind of doesn't matter because if you can't get it, make it up. I'm going to cover that up. Where do we start? The beginning. Are we taking our x values or our y values? X values, and then we're going to multiply them by 1/2 and add nothing. All right, so what's our first x value? 1 times 1/2, 1/2. Dang it. And then the next one is 0 is 0. Good job. Kind words. We're getting good at that. And then the next one will be -1/2. And then back to 0. And then back where you started. All right, so plotting these on here, look, you have to count by fourths. Are you seeing this? These are all fourths. Here's the easiest way to do this. This will be a 4th, 2/4, 3/4. I'm going to make this one be 1 whole pi. And then you can just count out like 4 more and make that 2 pi. and then count out 4 more and make that 3 pi. You don't have to label each individual one. In fact, I'd rather you didn't, because it's tedious and annoying and it's tiny. Like, just label enough of them so that we can count by fourths. Now, this is going to be a really shallow wave, because remember, we scrunched it. We vertically shrunk it, I should say. All right, so negative pi over 4, that's going to be this little tick mark here, negative a fourth. We want to be at a half. So right there. And then positive a fourth is 0. That's right there. And then 3/4 is negative a half. 5/4, we're back to 0. And then 7/4 is a half. So again, it's really like a shallow wave. And when you go to continue this one, do you see how every other tick mark got skipped? That happens sometimes because mathematically it was just because of how it got shifted. Do you see how every other tick mark doesn't have a point? So when you keep the pattern going, you're going to have to skip every other one. So I'm going to skip this one. Where will the next one be? I'm going to skip this one. Where's my next point? 0, good. Skip 1, and then it's negative a half. Skip 1, and then you're back to 0. Skip 1, and you're back to positive a half. So it's mostly about pattern finding more than anything else.